Hello class, we are towards the end of this chapter. Yesterday I gave you a program on queue. You have seen that how to make use of item node. What is item node? Item node is basically an element in the queue which is not a single unit, which could be made up of more than one unit. Then we call it an item node. And we have seen that we create the item node first and then we push it in to a queue. Similarly, when we remove an item node, we remove the complete thing, that is all the components, and it is basically implemented by a nested list. That also we have seen. Today we will see two applications of queue. Okay, I am not very sure the programming part of this is required for your syllabus or not, because it doesn't say very clearly. So I will just look into one or two resources and then I will decide whether to do the programming or not. But theoretically you need to know. In fact, in your textbook they have given only the theoretical explanation. There is no programming application of that. That we can decide later. First of all, let us understand what these topics are. Okay, it's related to queue. What is it? One is circular queue. Okay. One is circular queue. What is circular queue? Circular queue, first of all, is a queue which will be bounded. Bounded means it has basically a collection of cells which are fixed. Now pay attention to this very carefully. One or two of you have asked me this question and I have explained to you that queue is basically a concept. We are trying to visualize that concept through list, because list is there in your syllabus. But actually the queue concept is to be done through another collection of data items which is called array. Right? Now since arrays are bounded, okay, array will always have a fixed size. Like when you declare an array, you can very clearly mention that I need 10 cells, or I need 15 cells, or I need 20 cells. Okay. But in case of list, we have seen that it's not bounded. Fine. We don't have to worry about the size of the list. If I feel like to take 20 elements, I can do so. If I feel like to take 50 elements, then also I can do. Okay, I can take any number of elements. Fine. So handling list becomes much easier, right? So we will try to imagine as if an array is given to us. Forget about the list for time being, because the list will not have a bounded situation. Okay. And in this topic, we need to imagine a situation where we are given a collection of cells which are bounded. There are fixed number of cells. Then only this concept we can realize. So quite naturally, programming part of circular queue will not be possible, because in list, since we cannot have a bounded situation, we cannot have circular queue. But theoretically what it is, that you need to know, because it is given in your textbook. Circular queue is first of all a linear queue. Fine, if I imagine a queue like this, okay, and imagine that queue I bent like this. I bent the queue like this. So it has taken the form of a circle, right? Or circular in shape, right? So, and these are the cells. Now what is the utility of that? What is the point of thinking an array in a circular manner? Imagine these are the cells 0, 1, 2, 3, 4, 5, 6. It is, I told you, it is a bounded kind of situation. Say, whole thing has to happen, say, within these 7 cells. Okay? Now, supposing we have some numbers 29, 36, 15, 87. These are the numbers stored. So at this moment, what will happen? Whichever we know, whichever cell holds the element first, the index number, that is called front. So basically this will be my front. So we can say here the front is 0, and we can say the rear is basically 3. Right? Now obviously you can make out, if I insert, what will happen? The rear will increase. Right? So if I insert another number, say I inserted a number 92. What will happen now? Rear will change. From 3, the rear will become now 4. That is how insertion goes on. Because we know that insertion has to take place from the rear end. Okay. That means the basic concept of queue we follow here. We delete from the front and we insert from the rear. Okay. Now, if I imagine started removing them, I remove 29, I remove 36. What will happen to front? Front will obviously become, right? Now, at this stage, just follow me up very carefully. Then you will understand the concept of circular queue. At this stage, I inserted 2 more numbers. I inserted number 55 and I inserted another number 65. So, what will happen to my rear? My rear will be 6. Now at this stage, we can easily make out the array is not full. Okay? Array is not full. There are 2 cells which are still vacant. Fine? Now at this stage, if any insertion has to happen, if I want to insert, question is, can I insert? Yes, we can insert. Then what will happen to rear? Since the array is not full, pay attention to this carefully. Since we can see vacant cells are there, so the rule is rear from the last cell will shift to 0th cell. That means rear from here will go back there. And the new number is say 10, which was inserted. So now rear will become 0. And front will remain at 2. It's giving a very funny kind of situation, but that is how it is. Right? That means here what is happening is rear, look at this, moving like this, right? As we insert the elements, when the rear comes here, if there is a vacant cell in the 0th cell or first cell, then it can go back like this. That is why it is called circular queue. As if front and rear, both of them are capable of moving in a circular path. That is why it is called circular queue. So just like the way whatever has happened to rear, same thing can happen with the front also. Imagine I started removing all these elements. I have removed. Here front will be now. Okay, because I have removed all of them. At this stage, if I want to do pop 1 second or DQ 1 second, then what will happen? 65 will be out. So where front will go? Front will go there. So look at this, front is also making a move in a circular path. That is why this kind of queue is called circular queue. So we can say the circular queue happens first of all in a bounded situation, that is feature number 1. And in the feature number 2, we saw what happens, it is a contiguous in nature. That means the queue is not finished here. We can, if we want, and logically if it is possible, we can move back to the 0th cell. That's why we are saying it is contiguous in nature. Right? That is all about circular queue. Right? Now, since it is, again I am repeating, since it is in a bounded situation, it happens only in a bounded situation. That means with a fixed number of cells. So we cannot implement that through list. It's impractical to implement that through a list. Fine? Okay. The second thing which I am going to tell you today